So this is a 15-minute talk, so I'll go very quickly through things. I'll also not take any questions, but if you have any questions, I'm happy to answer them afterwards. So yeah, I'm Danilo Machado. I'm a solutions architect for AWS based out of Belgium. Have a background in mathematics and have been doing a bit of machine learning. And not only me, but also at Amazon, we have a long heritage of machine learning, starting from the recommendations that you get when you buy items at Amazon, initially with books. Then the Kiva robots in our centers. So in our fulfillment centers, we have more than 100,000 Kiva robots to help the logistics of that. Drones with Prime Air, Amazon Alexa, and of course, I don't know if any of you know the Amazon Go store, where you can basically scan in your phone, put it away, pick up whatever items you want, and just walk out, and you get billed for everything that you picked up. So yeah, we have this history with artificial intelligence and machine learning. And at AWS specifically, our mission is actually to put machine learning at the hands of every developer, and really to make it easy and reduce complexity and give as many solutions as possible for just about any public. So why do people want to use AWS for machine learning? Well, we do have the broadest and deepest set of AI and ML capabilities out there. Just last year, we released more than 200 features, and the pace of innovation is just increasing, so we expect even more this year. We have platform or collections of services like SageMaker, where we try to help with not only reducing the complexity, but also reducing the cost of doing machine learning to make it really easier to adopt and easier to do things, taking away a lot of the heavy lifting and doing that as part of a managed service. And you're also inside the AWS cloud, where we have all these capabilities in 165 plus services and all the availability zones in the global infrastructure. So yeah, in terms of machine learning, and as I mentioned, this is a short talk. We'll get to more detailed on Spark and a little bit on SageMaker. But we always start from our customer. And we like to say we start from our customers and work backwards. So we have a lot of different references, a lot of customers doing machine learning, more than twice the references as anybody out there, more than 10,000 customers. If you look at TensorFlow, 85% of all TensorFlow projects that run the cloud, they run on AWS. But I mean, what is it that we do at AWS for machine learning? So actually, we have it in about 3 layers. So that's just a way to simplify how we organize things. So basically, if you look at the top there with the AI services, we have a number of different pre-trained services that any developer without any knowledge of machine learning can consume and integrate as part of their application or build applications based on that. And these services go from recognition and text track, which are more vision-based services. So recognition does image analysis, and text track is an OCR service for getting text out of documents, can be images or anything else. From speech services, language, chatbots, so conversational chatbots, which are kind of similar to Alexa, but you can actually build your own conversational chatbot with Lex. And even down to forecasting and recommendations, so services where a little bit more knowledge is needed, but with very few effort, in a few hours, you can have a recommendation engine or forecasting. But if you go a little bit down to more machine learning, especially for developers, they're building their own models. We have SageMaker, and inside SageMaker, there are a number of services to make the life easier for the developers. So when we talk about labeling, for instance, where a lot of effort goes into labeling, we have SageMaker Ground Truth that will help in this effort, not only by doing some automatic labeling, but also for you to use things like Amazon Mechanical Turk, where you can do the labeling with third-party or even your own private workforce. But we help to organize this so that to remove this complexity or to make it less complex for people to adopt this. So I'll dive a little bit deeper into SageMaker and a few of the services around SageMaker. But mainly, if you look at any of these boxes, we're trying to help with a lot of these things that you need to do in machine learning, from labeling to managing your algorithms to deployment to training. And we have services to help along the way there. But it doesn't stop there. If we have expert data scientists that really want to go down to the infrastructure level, to framework level, and optimize for specific hardware and get the most out of the machines, we have a collection of different services and frameworks to help there. We are framework agnostic at AWS, so from TensorFlow, MXNet, PyTorch, or bring your own framework, we have a number of different things and different images to help you get started on this. And you get services like, not only the instance sizes that are there, the P3 instance size, for example, and the G4 instance sizes, but we have services like Elastic Inference and Greengrass and FPGAs available. So Greengrass, for instance, for you to be able to actually deploy some of the machine learning that you do at different edges, at different devices. So I'll talk a little bit about Elastic Inference, as you know, the time is short, just to give you an overview of it. So SageMaker ground truth. So as I mentioned about labeling, well, labeling is hard and it's a lot of work. So we made ground truth where you can combine, well, actually you can have human annotations, and we use that as reference to provide automatic annotations and more human annotations based on workforces that you configure. And we have an entire user interface for doing this to really help with the labeling. So with Amazon Mechanical Turk, for example, if your data can be publicly available, you can use workforce which is spread out around the world to do the labeling for you, and you have an interface to actually show to them what a good labeling job is like, what a bad one is, and you get the results. And you can also feed that in to the automatic labeling so that you get as much automatic as possible. So SageMaker also, on the algorithms part, it comes with a number of built-in algorithms. I don't even say how many because it changes all the time. I remember when it was 8. Now there are over 15 algorithms that come with SageMaker on multiple areas, from ResNet on image processing to fraud detection. So there are a number of different algorithms, anomaly detection, regression, and so on. And you can also bring your own algorithm. You can also bring into SageMaker so that you can benefit from one-click training and one-click deployment. So if you containerize your algorithm, and we have even tutorials on how to do that, you can actually bring your own containerized algorithm into SageMaker and benefit from a lot of the things that are inside of SageMaker. Yeah, some information about it. One nice thing about SageMaker is that you don't need to copy the data from one place to the other if your data is in S3 or a simple storage service, so it's already stored on AWS. SageMaker can use that data via streaming, so you can actually just stream the data. You don't need to copy it, move it, duplicate it, and etc. It has a really nice feature around checkpointing. So if you're doing a training, for example, of your machine learning algorithm, actually if you take a built-in algorithm, the checkpointing is automatic. But even if you bring your own, you have a way to implement checkpointing, meaning that while you're training, let's say that you're training for so many epochs, but along the way, in the middle, you actually had the algorithm performing better than at the very end for whatever reason, you can actually take that checkpoint and use that as your model and deploy it. We implemented it for a number of different reasons. So also being able to use spot instances, which are cheaper instances that you can use, which can be reclaimed. And then checkpointing helps so that the training can continue from the point it has stopped. But it also gives you the advantage of being able to use an intermediate result if that is better. OK, so SageMaker, as I mentioned, you have the ability of doing one-click training. You can do that in the UI of SageMaker. Actually, you can also do it via an API call. So let's say if you have your own development environment, you're using PyCharm or another IDE, and you want to use the one-click training, for example, or you can actually just do an API call to do the training, and you spin up all the infrastructure needed. You got to give it what kind of infrastructure that you need, but it can handle self-scaling. It can handle all the things for you, and you only pay for the time that it was actually training. So we will tell you how long it ran and so on. So these are the things in SageMaker. to help make the life easier of a machine learning practitioner, data scientist. And with SageMaker Neo, we actually aim at something else. With SageMaker Neo, we try to optimize models for different hardwares, because oftentimes you build a model and it's, I don't know, you intend to run it on NVIDIA hardware, you optimize for it, especially at the infrastructure layer, but then all of a sudden you want to run it on another hardware. Well, you need to re-optimize sometimes. It can be a tedious process. With SageMaker Neo, it kind of goes like a bytecode type of, it's not really bytecode, but a bytecode similar type of process where things get precompiled, and inside of the different hardwares it can run. And due to the optimizations that are done, you actually get a highly optimized code in the end, which may not be 100% identical to the code that you had, because the process actually modifies a little bit, but it's nearly identical to the code that you had with, and optimized for all this hardware, and in benchmarks getting sometimes even double the performance that you normally would with an unoptimized algorithm. So you've done your training, labeling, and so on. You need to deploy. Yeah, just like one-click deployment, we also have one-click training. You also have one-click deployment, where you can do all kinds of things from letting the endpoints auto-scale, doing A/B testing, for example, so that you configure, well, I want 30% of the traffic to go to this endpoint or that endpoint, which can be also nice for versioning of your endpoints and to make sure that you get everything working correctly. You can, once again, you can deploy with your own model, and you have a Python SDK to make calls and to use these functionalities, these services actually as calls inside your code. So you don't actually need to be inside an AWS environment to do this. You can do it in your own IDE. As I mentioned, so SageMaker, we talk more about the infrastructure layer. One service that I wanted to mention as my time runs down is Elastic Inference. And basically, Elastic Inference provides you the ability to attach GPU to to specific EC2 instances, to specific compute instances in an elastic manner, so that it can actually auto-scale the number of GPUs according to the workload that you have. So this gives you the capability, let's say that your algorithm needs, it's GPU intensive for training, but maybe not during deployment, during inference. So with Elastic Inference, you can auto-scale the number of GPUs attached during your training, even according to need. And during your inference, it can be that you're using less, and Elastic Inference will handle that. And of course, then reduce the cost and having less machinery that is not being underutilized. So it's a way that we've helped our customers to improve on this. But okay, this is a Spark conference. I've been talking a lot about AWS services and all of that. I wish, like I said, I could pop open my IDE and do some Spark coding, but in 15 minutes, well, we could get somewhere, but not so far. But okay, how can you run Spark on AWS? So we talked about SageMaker, and we have a SageMaker Spark where you can run Spark inside of SageMaker, and SageMaker will actually manage the cluster underneath for you. But you can also use serverless with PySpark on AWS Glue. You can also do it in Scala, of course. But with AWS Glue, it's a serverless service to do ETL, basically. You can also run Spark on EMR, on Elastic MapReduce, so our managed Hadoop service, basically, where you can have your own notebooks there. But you can also run on EC2 instances, so on compute, on regular virtual machines, on ECS, so Elastic Container Service, if you have your model containerized, or EKS, if you use Kubernetes with our Elastic Kubernetes service. You can also run your Spark code there. And moreover, not to be underestimated, there's also a number of different offerings on the AWS Marketplace, from Qubole to Databricks to Hortonworks, where obviously you can run your Spark workloads as well. So I zoom into one of them as I have only a few seconds left. And this is, for example, an implementation of a data lake with AWS and Databricks, where the ingestion of the data coming through batch or real time, so coming through Kinesis or managed streaming for Kafka, for example, that can go into Databricks Delta in this case, with an underlying storage on S3. And from that point on, you can use SageMaker to create your custom model, or you can store that data on RDS, or our relational database service, and of course consume from applications or visualize with things like QuickSight to visualize your data. I just want to point out, as my time is over, that tomorrow at 4:40 there's a talk by Dennis from Databricks, where he'll actually have 40 minutes and he'll dive deep into building a data lake with inside AWS with Databricks Delta. So for you guys interested, please check it out. And at ml.aws, you can also see a lot about machine learning at AWS, including the machine learning certification that we have, training materials. We have a lot of digital training free, actually for anybody, really with dozens of trainings that you can find there, and other informations, references, and that's pretty much about it. All right. Thank you, guys. Yeah.
Great. Thank you very much, Danilo. And if you guys have any other further questions, please visit the booth and to learn more about the AWS stack. Thanks again. And remember to rate all the talks within the Spark Summit EU app.